Hello everyone, we are starting with the Klein-Gordon equation. We will be deriving Klein-Gordon equation and understanding each step involved in it. So basically the starting point is that we have a correspondence principle, we know that, and where energy can be written, classical energy can be written in an operator form as IH cross del over del T, and momentum can be written as h cross over I del. Okay. Now also we know that the Hamiltonian can be written as E is equals to p square over 2m plus v, and for a free particle where potential is 0 we can write E is equals to p square over 2m. Okay. Now when E act on psi and p square over 2m act on psi, then this particular thing in an operator form can be written as I h cross del over del t acting on a psi is equals to, how can you write p square, this particular thing we can write p square is equals to h cut square del square over I square, and we know that I square is minus 1, so I will just write del square h cut square del square with a negative sign. So with a negative sign, del square h cut square which is acting on a psi basically can be written like this, h cut square del square acting on a psi over 2m. So this is what, this is a Schrodinger equation, and as we can see, this is the time part and this is the space part. Okay. And they have different order, like time has a first derivative, space has a second derivative in symbol language, and due to this is not Lorentz invariant, Lorentz covariant in general. Okay, so there was a need for a equation like a Schrodinger equation in relativistic quantum mechanics, basically in relativistic domain, that there is a need for a relativistic Schrodinger equation, and for that there was many scientists which came, basically physicists which came. So Klein-Gordon and many others write a KG equation, and I will be deriving that particular thing. So the starting point of that derivation is as we have seen in the first slide, that energy is in the operator form and momentum in operator form. Now energy momentum relation, we know that, and we can also derive it from special relativity. E is equals to under root of p square c square plus m square c power 4. Okay, this p square can be written as from the earlier slide we can see that h square del square c square plus m square c power 4. Now this is E. In this way, how can I write the way I have written here, like in this form, in this type of form? So this is the root. So if we take a Taylor expansion, then we will have orders of del square, okay, which we don't need. So what we will be doing is just squaring this equation. So I get this h square del square c square plus m square c power 4, and this act on psi basically. Okay. Now we know that what is the E square? E square is just, we know that E is equals to I h cross dou over dou t act on psi. So E square can be written as I h cut whole square dou psi over dou t, sorry, d2 psi over dt square. So I will write this thing here, and that d2 psi over dt square, and this is I h cut whole square with the same thing, q square plus m square c power 4, which is acting on a psi. Now what we understand from here is we have this particular equation. Now I have to introduce you something called 4 vector. And what is 4 vector is just writing space and time. Like earlier we used to write x, y, z axis. So what they have said that the third axis is the time axis, basically the first they have considered, and they have written this thing as x naught, y naught, z naught, sorry, x naught, x1, x2, x naught, x1, x2, x3, where x naught is ct, x1 is x, x2 is y, and x3 is z. Now this del square is a space part, so it is x1, okay, plus del square del x2 plus del square del x3 square. Okay. Now what is that this thing? This is all the x1, x2, x3. It contains all x1, x2, x3, and this contain x naught. Now how can I write it in terms of x naught? Is just multiply c square and divide by c square. So if I multiply c square and divide by c square, I get c square h cross square with a negative sign. Why it is a negative sign? Because when you square h cross, when I minus I square, basically I square and h cut square, which is minus h cut square. Okay, from here I can see it. Okay, I will just write d2 psi over dou ct whole square. C square, this thing. Now this is x naught. Okay, so I will just write it as x naught square, because ct is x naught in 4 vector. So this is equals to negative of as earlier h cut square del square plus m square c power 4 whole time psi. Now I want to rearrange this particular thing. So how can I rearrange this so that I will get it? Sorry, one more thing I am missing. What I am missing here is this thing, c square. So I can take into the left hand side, or basically adding h cut square del square c square on both sides. So we will get minus c square h cut square as common, and this will be d2 over dx naught square, okay, plus with a minus sign del square. Oh, act on psi give you m square c power. Now how does this is rearranged is that this whole thing came here. Now this sign, don't consider this as a this whole bunch came here, and then there is a negative sign over this. So I have taken this thing as common, so therefore this is shifted, and this minus c square h cut square is common. So since it came here in the left side, this is a negative. Okay, you can do this particular thing on your notebook and you can see it. Okay, now this particular thing is in 4 vector notation is del u, this thing. Okay, this is a contravariant, this is a covariant. Okay, and where this del nu can be written as d over d, sorry, with a and this can be written as with the upper. So this is all about the 4 vector notation and nothing much. Okay, so we have minus h cross square c square del nu del with a mu, okay, over the upper contravariant wala. act on psi, which is m square c power 4 psi. Okay, now dividing the whole equation by minus h cross square psi c square. So if we divide this, then okay, so we get del nu del with the upper mu act on a psi is m square c square over h cross square is a negative sign. Act on a psi, so I can write this equation as plus m square c square over h cross square. Act on a psi is 0. This is basically a Klein-Gordon equation. So talking about this particular term, this is also called this box, and this is called D'Alembert operator. Okay, so this is called, this is box and this is D'Alembert operator. And this term, the m square c square over h cut square, basically in this notation it is 1 upon lambda. Okay, and this is called 1 upon lambda square. This is called Compton wavelength. Okay, we know that Compton wavelength is lambda is h cross upon mc. Okay, and this D'Alembert operator is Lorentz invariant. Okay, so this is all about the Klein-Gordon equation. And the drawbacks of Klein-Gordon equation is, number one is it has negative energy solution. How negative energy solution is, because E square is equals to P square C square plus M square C power 4. So you have energy E is equals to plus minus of root. So there is a positive energy and a negative energy solution. Okay, and one more thing is that is it Dirac equation cannot define like spin half, spin of an electron. So that is it for this lecture. Thank you so much.